We skipped this section in class, so if you want to just push pause and kind of mark these things down. But the average velocity is the first, different color. So the average velocity is displacement over time. And think of that as on a graph, a secant line. So remember, secant lines, they cross the curve twice instead of once, like a tangent line. And then to work your way from average velocity to instantaneous velocity, suppose you would compute the average velocity over shorter and shorter time intervals. So like this interval is getting closer and closer to 0. Instantaneous velocity is the limit of all of these velocities. So if you want to just kind of pause and write that down, and that's the same, we ended up using this equation to do the problem that we began. So we began this problem in morning class, and we got here. And then, so where I'm going to take over is how fast is the ball going to be traveling when it hits the ground? Well, the first thing you're going to have to find out is when does the ball hit the ground? So we know it's from the CN tower, that's 450 meters. So the formula, we're going to just set our formula equal to 450 meters. Like how long, T is time, how long is this ball need to travel? So it's kind of like at the top of this tower, and you know, you're going to throw it off, and we're trying to figure out first of all, what's the time when it hits the ground. So we just set our equation equal to 450 because that's how far we need to travel. And I just solve for t, and I square root. We obviously only want a positive answer for this, and you get 9.6 seconds. So we just solved that with a calculator. So it's going to take, this is the time down here, it's going to take 9.6 seconds for it to hit the ground. Now that we know time, to find how fast the ball is traveling when it hits the ground, we're going to plug in our 9.6 seconds in to our equation. So you're just going to take 9.8 times 9.6, velocity times time, and then we find out what happens is this ball is traveling 94 meters per second right when it hits the ground. Then it's probably going to bounce and things, but that's how fast the ball's traveling when it hits the ground. Okay. So if you flip the page, and let's talk about this problem. So here we have a function. This is just a parabola, 1/2 t squared minus 6t plus 23. And all I really did here is I just, plugged in some values. The vertex is right at 6.5. It hits the point 8.7 and also 10.13. So if you wanted to kind of pause and just sketch your parabola, that'd probably be a good thing to do to start. Okay. So that's my red parabola right here. The vertex is at 6.5, includes the point 8.7 and 10.13. They want us to find the average interval over the time from 8 to 10. So like if we go time 8 to time 10, that would be this line right here. So this is secant line, correct? It'd be this green secant line. And what I'm interested in is knowing what the slope of that line is. So you guys should just be able to figure out slope, rise over run. Well, we rise 6 and we run 2. So our slope is 3 for that interval. And let me pick a different color. From 6 to 8, so from time 6 to time 8, that'd be this orange secant line. And the slope of this is rise 2, run 2. So our slope would be 1. So what's the average velocity? You would just average those two numbers and you get an average velocity of 2. So what we're going to find out now is what is the instantaneous velocity at exactly 8 seconds. So what we're trying to find is kind of the tangent line slope at 8 seconds. So here's my tangent line right here, and I want to kind of find what that slope is. So for instantaneous velocity, we just want to get kind of closer and closer to 8. So what I did is I just, in a calculator, I plugged 7.99 into the function and got a velocity of 6.98. And 8 we know is 7. We already know that point on the graph. So let's just kind of calculate the slope here. Change in y over change in x. would be 0.02 over 0.01. Oh, that's equal to 2. And then I went another step further, 8.01. I plugged that into the function. I got 7.02005. And then I kind of found the slope between these two values. And you can see that's really close to 2. So that's kind of what instantaneous velocity, like this is kind of doing this by hand. It's kind of like this slope keeps getting closer and closer and closer to the number 2. It wants us to sketch the graph. Well, we kind of already did part C up here. Sketch the graph S with the secant lines and the tangent lines from part A and B. Okay, and I wish this wasn't at the bottom of this page. And if you can't read this very well, look in your book. We're now getting to what the definition of a derivative is. And if you want to kind of make a note, the derivative is the slope of the tangent line. That's what a derivative finds for us, is the slope of a tangent line. And the way that we denote a derivative, it just has this little dash, so f dash a, and then take time to write this down. You can look in your book if you can't read my writing, but I definitely want you to have this formula down before you move on to the next page, page 29. Okay, and I'm going to do this one with you. Find the derivative of the function f of x equals x squared minus 8x plus 9 at a. So the derivative, f prime of a, equals the limit as x approaches 0. So we're kind of, so instead of h approaches 0, I'm just using an x. Okay, and, or you know what? Sorry, I think I should change that to say h. I'm just so used to writing x. Make that say h right here. So the limit as h approaches 0. All right, let me do this. Let me put my formula here. So what you have to do, this is really annoying, you have to plug a plus h into the formula, and you have to plug in f of a into the formula, and that's pretty easy. So first, if I'm going to plug f of a plus h, that's the step I'm doing right now, is I would have to write the x squared as a plus h squared minus 8 times a plus h plus 9. So that's my, and I kind of put that in brackets. That's my f of a plus h. Then we're going to subtract, and make sure you put this in parentheses or brackets, f of a. So that's easy. You just change these to a's. A squared minus 8a plus 9. And then you take all of that and you divide by h. So as this limit gets closer, as this h value gets closer and closer and closer to 0, we're trying to evaluate what this function is going to look like. And this, again, is going to find the derivative or the slope of our function at any given point a. So our final answer is going to have an a in our answer. So now all we have to do is just do a little bit of algebra, a lot of algebra, I guess. So I'm going to go ahead and FOIL this. You can go ahead and try to do this too. A squared plus 2ah plus h squared minus 8a minus 8h plus 9. And there's nothing really we can do with this second one. And all, that's a 9. And all over h. So now we're just going to start canceling out some things. And hopefully you realize this a squared minus this a squared are going to cancel. Do you see how this is a negative? So a negative negative is really a positive 8, right? So you have a negative 8a and you have a positive 8a. So those are going to cancel. Same with a 9. This is a 9 minus 9. Those are going to cancel. So let's write down what we have left. Limit as h approaches 0. We have 2ah plus h squared minus 8h, all divided by h. And you should hopefully see we can factor an h out of the numerator. And then once we do that, we can cancel out our h's. And now we can apply what's going to happen as h approaches 0. Well, 2a is not affected by that. This will become 0, and minus 8 is not affected. So what we have just found is the derivative of this function at a is equal to 2a minus 8. What does this mean? The slope of the tangent line at f of a will equal this value. So if you want to know what happens at a equals 2 or a equals 7 or as a equals 10, you can kind of plug that into this problem. So, all right, so let's do this example. I totally screwed it up. I'm going to try again. I'm going to use pencil this time. Okay, so our function is x to the negative 2. And if you guys remember from Algebra 1, you can write that as 1 over x squared. I think that's easier in doing this problem. So if we're going to find the derivative of this, so f prime of a equals the limit as h approaches 0. All right, in the numerator we're going to do f of a plus h. So we're going to replace our x with a plus h. So it'll be a plus h in parentheses squared, minus f of a, well that just becomes 1 over a squared, all over h. Okay, so we have a fraction within a fraction, but let's go ahead and deal with just our top fraction, and let's deal with getting common denominators. So our common denominator is going to be a squared times a plus h squared. So this fraction needs an a squared, and can you imagine if you cancel these, you get back to where you started, so it's fair. And this fraction needs an a plus h squared, like that. So right now we're just going to kind of keep doing some algebra. So what we're allowed to now do, we have just this h on the bottom, and I have this fraction and a fraction. Okay, and in the numerator, I'm going to write this as a squared minus, and I'm going to go ahead and FOIL this, a squared plus 2ah plus h squared. And we're just simplifying right now. Okay, so this a squared minus this a squared, that's going to cancel. I think I have room to write one more row. Okay, so this is my denominator of my upper fraction. And then here, remember this is a minus sign, so be careful. Factor that negative. So it will become negative 2ah minus h squared. So let's see if we can simplify this a little bit more. Okay, so here's what I'm going to do. I'm going to write a fraction on the bottom, h over 1. Do you guys remember when you divide fractions, keep, change, flip? Don't forget to write. We're still finding the limit here. So we're going to keep the first fraction as negative 2ah minus h squared over a squared, a plus h squared, and we're going to multiply by the reciprocal, 1 over h. And what that's going to accomplish for us is we're going to be able to cancel out h's. Okay, I'm going to save myself some room, and right here I'm going to factor out an h from this numerator. It'll become negative 2a minus h, just to save myself some room. And now I'm allowed to cancel out my h's. So let's see what we have. So our numerator, we're just multiplying by 1. That's easy. Just negative 2a minus h. That's our numerator. And our denominator is a squared times a plus h squared. Okay, now let's see what happens now if we would plug in a 0 in for our limit. Okay, so if we, as h approaches 0, this is going to still just be negative 2a, but then you're going to have minus 0 over a squared times a plus 0 squared. Okay, and that's going to leave us with negative 2a over, do you agree this is just a squared times a squared, a to the 4th, and we can cancel out an a, leaving us negative 2 over a to the 3rd, and that is the correct final answer. A lot of work, but that is the correct final answer for that problem. The last 3 pages we are going to finish in class the next time you're in class, which will be on Thursday. So we're just going to kind of stop there. So to get credit for the videos, you will have completed everything that we just completed on this video.